Welcome to the deep dive. Today we are strapping ourselves in, really, for a look at the high-voltage history of electricity. We're going to dissect the complex, often contradictory, but undeniably brilliant mind of Nikola Tesla.
The Serbian-American engineer, futurist, inventor, lived 1856 to 1943.
Exactly. And you know him, of course, because his work basically powers your entire life. We're talking about the modern alternating current, or AC, electricity system.
That's the cornerstone, yes. But Tesla's story, it's almost become, well, mythological, hasn't it? Often just boiled down to that famous rivalry with Thomas Edison.
The war of the currents.
Right. And while that's crucial, our mission today, personalized for you listening, is to dig much deeper. We want to really unpack the architecture of his mind, explore his biggest technical wins, and then...
This is fascinating.
Yes, look underground, beneath Shoreham, New York, at the mysterious infrastructure of his most ambitious failure, Wardenclyffe Tower.
We're talking about someone so fundamental, he's one of the very few scientists, like Ampere or Kelvin, who has an SI unit named after him, the Tesla, for magnetic flux density.
It really highlights his impact.
And the contrast is immediate, isn't it? Tesla, the visionary, mentally perfecting devices before touching a tool, versus Edison, the tinkerer, relying on relentless trial and error.
So let's unpack the brain that made that possible. To really grasp how Tesla came up with something like the rotary magnetic field, or later the magnifying transmitter, you first need to understand how his mind actually worked. It's quite unique.
It started young with some kind of affliction.
A peculiar one, yes. From childhood, he experienced these spontaneous, incredibly vivid images. But here's the thing. They weren't imagined. They were scenes he'd actually witnessed.
So not hallucinations in the typical sense.
No, pictures of real things constantly flashing up, often accompanied by these strong, really disruptive bursts of light. It sounded intensely disturbing.
Absolutely agonizing, you'd think, especially for a kid. It's not just a distraction. It sounds like a constant visual flood interfering with everything: sight, thoughts, actions.
Exactly. And his distress led him to instinctively start what he called mental journeys.
Yeah.
To try and banish these images from his reality.
You'd escape in his mind.
Precisely. He'd travel mentally, visiting new places, cities, countries he'd only read about, apparently in perfect detail. And he did this constantly, all the time, until he was, 17?
Wow. So a coping mechanism, basically a distraction technique, accidentally becomes the foundation for his entire inventive process later on. That's incredible.
It evolved into this method of complete three-dimensional visualization. He famously claimed he didn't need physical models or drawings or, endless experiments.
He could build it all in his head.
Build it, change it, improve it, operate the finished device entirely in his mind. And this is where we get to that core claim, maybe genius, maybe hubris. He stated, quite emphatically, that the mental experiment always worked exactly as he visualized it. He claimed not a single exception in 20 years.
Okay, I have to stop you there. Not a single exception. I mean, that's either a sign of a truly unique mind or, well, it sounds almost unbelievable, doesn't it? Edison's whole lab was built on failure, on trying things until something worked.
Right.
Are the sources really suggesting Tesla never had to prototype, never adjusted after building?
Well, he obviously had to build the final thing. But his claim was that the blueprint derived from the mental model was perfect, flawless. Any flaws were found and fixed in his mind, saving, huge amounts of time and materials.
So a radically different approach.
Radically different. And it maybe explains why he struggled later when these sort of perfect mental theories ran into the messy realities of funding, materials, actual people.
Makes sense. Now, moving from his mental process to his character, the sources mention a big shift, right? A sudden development of willpower.
Yes. He described himself up to age 8 as weak, easily swayed, even superstitious. But then he read this Serbian novel, Oafi, or The Son of Abba.
And that changed things.
He claimed it awakened his dormant powers of will, led him to practice really rigorous self-control, systematically conquering some major weaknesses.
Like gambling, right. And heavy smoking, things that could have ruined him.
He apparently beat both through sheer force of will, which says a lot about his self-discipline later. He also gave credit to his mother, Juka Mandic.
She was an inventor too, wasn't she? In her own right.
Yes, tools for the farm, intricate weaving. She clearly understood him. There's this great story about the gambling. She apparently told him, "Go and enjoy yourself. The sooner you lose all we possess, the better it will be. I know that you will get over it."
Wow. That's quite something. That kind of faith, almost a challenge, pushed him to stop. It really shows how personal support can shape genius.
It really does. And these early experiences definitely shaped the sensory quirks that governed his adult life. These weren't just odd habits. They were like compulsory rituals tied to his thinking.
Okay, let's get into those. The famous counting thing, for
Oh,
example.
absolutely. He had to count his steps when walking and calculate the cubicle contents of his food soup plates, coffee cups.
Calculate the volume.
Yes. And if he didn't or couldn't, the meal was apparently unenjoyable. And crucially, all repeated actions had to be divisible by 3.
Divisible by 3.
Yes. Like if he did something twice, he felt compelled to do it a third time, even if it took hours to get it right. Sneezes anything.
Why 3, though? It suggests this obsession with mathematical purity, even in everyday life. And his aversions were just as intense, almost like phobias.
Violent aversions, he called them. Women's earrings apparently caused him real discomfort. Peaches could give him a fever, he claimed. Hated the smell of camphor. Loved crystals, but couldn't stand the sight of a pearl. But he connected it all, you see. These compulsions, these aversions. He saw them as linked to his intense focus on cause and effect, how external things impacted his thoughts. And he said this led directly to his practical concept of teleautomatics.
That's a fascinating link. His own mind, working by these strict, almost mechanical rules, became the blueprint for remote-controlled machines.
Exactly. Before we leave his early life, though, we have to touch on his recoveries from illness. They seem almost miraculous and really shaped his later views.
He had some serious bouts, right? Cholera.
Multiple near-fatal illnesses. Cholera, yes, where doctors apparently gave him up for dead at one point. And later, a complete nervous breakdown in Budapest.
What did that involve?
He described it as excruciating hypersensitivity. Hearing a fly land on a table sounded like a deafening thud. He could hear a watch ticking 3 rooms away. His pulse was apparently all over the place, from barely beating to 150 a minute. A total sensory overload.
Just a complete collapse. How did he pull through that?
Well, part of his recovery he attributed to reading Mark Twain, the early works.
Mark Twain.
Really? He found the humor therapeutic. Years later, he actually told Twain this story, how his writing helped save his life, and apparently, Twain, the great humorist, was moved to tears.
Wow.
And these experiences, surviving these near-death events, they feed into a really interesting contradiction in his thinking later on, which we should definitely come back to at the end.
Okay, let's pivot now to the moment that really fundamentally changed everything, the invention of the alternating current system. It started when he was a student, right? In grads.
Yes, at the Polytechnic School. Second year, his professor, Professor Poschel, was demonstrating a Graham dynamo.
Which was DC, direct current.
Right. And it used a commutator and brushes these mechanical parts that constantly sparked wasted energy, needed maintenance. Tesla watched this.
And thought there had to be a better way.
Exactly. He got the idea of a motor without those sparking parts. A commutatorless system driven purely by magnetism.
Which back then must have sounded like, well, like you said, perpetual motion nonsense.
Pretty much. Professor Poschel flat out declared it impossible. Compared it to trying to convert gravity into rotation, a perpetual motion scheme.
But that just made Tesla more determined.
It seems so. The idea stuck with him. But the actual solution, the physics of the rotating magnetic field, that came later.
The famous flash of lightning moment in Budapest.
That's the story. He was walking in a park, reciting poetry Goethe's Faust, apparently with a friend, and suddenly, bam, the whole concept hit him.
Just like that.
Like a flash of lightning, he said. The complete understanding of how to use 2 or more alternating currents, slightly out of phase, to create this constantly rotating magnetic field. The key to AC power.
And he drew it right there.
Drew the diagram with a stick in the sand right there in the park to show his friend. That diagram, that was basically the birth certificate of the polyphase AC system.
And that moment led directly to the innovations that really powered the turn of the century.
Absolutely. First and foremost, the alternating current AC system itself became the global standard for transmitting power over long distances. Then, crucially, the AC induction motor in 1887.
Using that rotating field concept.
Exactly, to create motion without sparking brushes. That motor is fundamental to, well, almost all modern industry. And we should also mention the Tesla coil, 1891 high voltage, resonance circuits, laying groundwork for wireless tech.
But getting AC adopted wasn't easy. The business side, licensing it to Westinghouse Electric in '88, that's where the real battle began, the war of the currents.
Oh yes, that's where his genius met. Frankly, financial self-sabotage.
Yeah.
His deal with Westinghouse was incredible. A flat fee plus a royalty of $2.50 per horsepower generated.
Per horsepower, that's huge.
Huge. Westinghouse used AC to light the Chicago World's Fair, power Niagara Falls, but the company was struggling. Edison's DC campaign against AC was brutal, and just the cost of building the AC infrastructure was immense. They couldn't keep up with the royalty payments.
So Tesla, prioritizing the technology over his own fortune, did something drastic.
The famous story, yeah. He voluntarily ripped up the contract, forgave the massive royalty debt.
Just tore it up.
That's the legend. Estimates vary, but many agree. If Westinghouse had paid that $2.50 per horsepower, Tesla would likely have been the richest man in the world.
Yeah.
He sacrificed an unimaginable fortune to make sure AC succeeded.
Incredible. Now let's talk Edison. The competition. How did Tesla see him?
Tesla thought Edison was, well, inefficient. He saw him as lacking theory, relying on inventor's instinct and practical American sense, as he put it. Tesla felt a bit of calculation would have saved Edison like 90% of his trial and error effort.
It really shows that fundamental difference, the theorist versus the empiricist, the tinkerer.
Completely.
Yeah.
And the sources point out Edison's method was also about managing large teams. He'd employ engineers, then patent their collective work under his name.
Which explains the patent numbers. Edison had over 1,000.
1,093 patents, yeah. Compared to Tesla's fewer than 300 worldwide. Tesla was the lone wolf visionary. Edison was the shrewd manager of invention.
And Edison played rough in the War of the Currents, really attacked AC's safety.
Rough is putting it mild. It was vicious. Edison launched this public campaign to paint AC as deadly. He staged these gruesome public electrocutions of animals, dogs, horses, even an elephant, Topsy.
Just to scare people about high-voltage AC.
Exactly. And the darkest part was his involvement, or his allies' involvement, in designing the first electric chair, using AC current.
Wow.
It was a calculated move to forever link Tesla's current with death, with execution, to solidify public fear and nearly bankrupt Westinghouse. It was science versus brutal, brutal business tactics.
Yeah.
#3, the world system and the Wardenclyffe Enigma.
So AC was the industrial game changer, but Wardenclyffe, that was Tesla's ultimate dream, wasn't it? Almost a spiritual quest for global, maybe even free power. He called the magnifying transmitter at its heart his best invention.
Yes, and he specifically said it was meant to solve problems infinitely more important to mankind than mere industrial development. This wasn't just a bigger radio antenna. It was based on his deep dives into resonance, electrical and mechanical resonance, an idea partly sparked, apparently, by witnessing the power of an avalanche years earlier.
Okay, so how is this magnifying transmitter different from, say, Marconi's radio tech that was happening around the same time?
Totally different principle. Standard radio uses Hertzian waves they radiate out into space, getting weaker with distance, right? Tesla's idea was, well, radical. The magnifying transmitter was designed as a resonant transformer meant to excite the Earth itself.
Excite the Earth.
Yes, making Hertz wave radiation negligible. It was about creating continuous sinusoidal oscillations, not broadcasting through the air, but pulsing energy through the ground.
So using the planet as the conductor, not the atmosphere.
Exactly right. He defined it as a resonant transformer, accurately proportioned to fit the globe and its electrical constants. That was the leap. Tune into the Earth's resonance and distance becomes irrelevant. The whole globe is your transmission medium.
And this was the tech behind his incredible world system vision. What did that entail?
Oh, the goals were staggering. Instant wireless signals, global telephone network, he imagined receivers not bigger than a watch, universal news and music distribution, worldwide time synchronization with cheap clocks, and ultimately powering and controlling aerial machines wirelessly.
He was basically describing the internet, GPS, global broadcasting, all powered wirelessly in 1900.
Pretty much. And Wardenclyffe, the facility in Shoreham, New York, built around 1902, 1903, with that huge 57-meter tower that was meant to be the first node.
Financed by J.P. Morgan initially.
Primarily, yes. $150,000 from Morgan, who was keen on wireless telegraphy after talks with Marconi fell through.
But that's the rub, isn't it? Morgan thought he was funding communication, telegraphs.
But Tesla was secretly aiming for global power distribution. Wireless energy.
Which you couldn't easily put a meter on.
Exactly. Morgan realized Tesla planned to essentially give away energy, making it commercially unviable from his perspective. When Marconi sent that first transatlantic wireless signal in 1901, sort of beating Tesla publicly, Morgan pulled the plug.
So lack of funding killed it.
Lack of funding, yes, though Tesla also later said the world just wasn't prepared for it. But the biggest mystery of Wardenclyffe might be what's under it. Recent geophysics work has revealed some incredible stuff about the foundations.
More than just a base for a tower.
Much more. The footing itself was massive, a 28-meter octagon of reinforced concrete, but the depth.
Wow. Tesla reportedly dug a central vertical shaft down 36.6 meters. That's 112 feet, locals reported.
112 feet deep into glacial sediment, reaching the water table.
Reaching water at about 24 meters down, yes.
Now, 112 feet, that's not a standard metric number. Why that specific depth? Was it calculated for resonance or just to hit water? Almost certainly for resonance. To use the Earth as your conductor, you need to tune your transmitter, match its wavelength to the Earth's electrical properties. That might require grounding structures of very specific lengths, like a quarter or half wavelength. The depth suggests he was deliberately tapping into the aquifer, that conductive water table, using it as a massive ground connection to pump energy into the Earth effectively.
And modern geophysics, you mentioned methods like EI and GRV. Why those?
Because the site was demolished, filled in. Normal radar might struggle. But EI electrical resistivity imaging measures conductivity differences underground, and GRV microgravity detects density variations. They're good at finding buried structures, less bothered by surface mess, and they confirmed 6 tunnels connected to the tower base.
6 tunnels. Okay, let's break them down. The conduits first. Connecting the lab to the shaft.
Right, 2 main conduit tunnels. One on the east, likely the main electrical path, about 5 meters wide, 6 meters deep floor, big enough for heavy cables. Then a west tunnel, a bit bigger, 8 meters wide, 10 meters deep for, as Tesla described, communicating for bringing into the tower compressed air and water and such things. Basically, utility tunnels.
Okay, makes sense. But then there are the other 4. The exit tunnels, radiating outwards. Those sound mysterious.
They are the Enigma. The surveys show 4 tunnels, probably man-sized, maybe 75 meters long, angling up from the bottom of the main shaft at a precise 30-degree angle towards the surface.
Angling up towards the surface. What could they possibly be for?
That's the million-dollar question. Speculation includes better grounding over a wider area, safety valves maybe for pressure, or perhaps the most intriguing idea, maybe they were designed to somehow help resonate the aquifer itself in multiple directions to boost the world system's transmission. We just don't know for sure. Hashtag tag 2C. Other innovations in complex philosophies, while AC and Wardenclyffe get the headlines, Tesla's mind was just constantly working on other things. Hugely diverse crusts. He had patents in fluid propulsion, for instance, in Brazil, Canada, Mexico.
And he tried to revolutionize engines, right? The bladeless Tesla turbine.
Oh, yeah. He created these very innovative turbines. Smooth discs instead of blades, using fluid dynamics. Incredibly simple, potentially very efficient. He genuinely thought they would scrap all the heat engines in the world.
So why don't we have Tesla turbines in our cars?
Resistance. Purely commercial. He slammed right into the wall of invested capital. Think about it. Billions already sunk into piston engines, manufacturing, infrastructure, switching the whole world over. Even if it was better, theoretically, the economic inertia was just too massive.
Makes sense. He also had some pretty radical ideas about flying machines, didn't he? Even beyond turbines.
Way beyond. He envisioned aircraft devoid of sustaining planes, ailerons, propellers, and other external attachments.
So, no wings, no propellers. How would they fly?
Propelled entirely by reaction, he said, using his wireless power source somehow to create thrust, capable of immense speeds, controllable wirelessly from a transmitter like Wardenclyffe. It's like the earliest concept of directed energy propulsion.
Amazing. Now, let's loop back to that philosophical point you mentioned earlier, his idea that he was an automation.
Right. His intense self-observation, counting steps, calculating food volumes, it led him to this really profound, maybe unsettling conviction that he was just an automation endowed with power of movement, responding to the stimuli of the sense organs.
Believing life, even his own consciousness, was fundamentally mechanical.
Essentially, yes. And he saw this not just as a philosophical idea, but as the basis for a new technology, teleautomatics.
So the philosophy directly drove the invention again, remote control.
Absolutely. He demonstrated it spectacularly in 1898 at Madison Square Garden with a wirelessly controlled boat, caused a huge sensation.
And he immediately saw the military application.
He did. He envisioned automata, robots, basically, acting with limited reason, using them in warfare instead of soldiers. He predicted machines capable of destroying cities thousands of miles away. And he argued that true peace would only come when technology, his global systems, effectively eliminated distance, the physical cause of many conflicts.
His thinking also ventured into some complex and, by today's standards, quite controversial social areas, reflecting the scientific thought of his time.
Yes, and before we get into this, it's really important to stress, we're reporting what the sources say about his views to give a full picture. We're absolutely not endorsing these historical, sociological ideas.
Understood. So his views on human progress and society.
Well, his mind, which could envision global wireless power, also touched on areas like eugenics.
He actually advocated for eugenics.
He did. He expressed a belief that human pity had interfered with what he called the ruthless workings of nature, the process of natural selection. He was careful to say it wasn't about a master race, but more about a perceived need for society to manage population quality scientifically. It's a view that was unfortunately present among some scientific figures of that era.
A darker side of that early 20th century scientific rationalism. He also had predictions about gender roles.
Yes, he commented on the struggle for gender equality. He predicted women would eventually become the dominant sex, and the future would be run by, his term was queen bees. He saw it as a gradual, inevitable shift driven by social and economic changes.
Interesting. And politically, he had strong isolationist views for the U.S.
Particularly around World War I. In 1914, he argued strongly that the U.S. should stick to its traditions and avoid entangling alliances. He believed real peace wouldn't come from politics or war, but from universal enlightenment, maybe even the merging of races eventually, enabled by technology that eliminated distance. Always circling back to technological solutions for global problems, #TagV, the post-mortem and enduring legacy. It's quite the paradox. Despite the sheer scale of his intellect and the potential for immense wealth, Nikola Tesla died alone, penniless, in a New York hotel room in January 1943, right in the middle of World War II.
And the immediate aftermath was chaos, wasn't it? Panic about his supposed secret weapon, the death ray.
Exactly. Tesla had talked about, experimented with directed energy weapons. So naturally, wartime paranoia kicked in. 2 days after he died, the FBI ordered the Office of Alien Property Custodian to seize everything, all his belongings.
Even though he was a U.S. citizen.
Yes, he'd been naturalized since 1891. It just shows how serious the fear was, the fear that Nazi Germany might somehow get hold of his secrets.
So they needed someone to figure out if there was any real threat in his papers.
They brought in a top expert, John G. Trump, an MIT professor, respected electrical engineer, and yes, later known as the uncle of Donald Trump.
And what did Trump find?
He spent 3 days going through everything. The papers, a supposed prototype, his conclusion. Nothing hazardous, nothing militarily game-changing, certainly nothing resembling a functional death ray.
But the story about the prototype Tesla left in a hotel vault, that's pure Tesla, isn't it?
Oh, it's the perfect final act of showmanship. Tesla had left this box, claimed it was worth $10,000, warned it would detonate if opened incorrectly, sent the hotel staff running for cover.
And inside.
Professor Trump carefully opens it and finds a Wheatstone bridge.
A Wheatstone bridge. That's just a basic electrical measurement tool.
Exactly. A mundane piece of lab equipment. Worthless, really. It was just Tesla being theatrical, maybe having one last laugh at the world's expense.
But that fear, that government seizure, ironically helped preserve his work, didn't it?
It did. His papers were secured, analyzed, and eventually sent to the Nikola Tesla Museum in Belgrade. So his scientific legacy was largely kept intact, thankfully. But we should also mention his later life saw his eccentricities really intensify.
He remained a lifelong bachelor, chose celibacy, believing it helped his science, though he later regretted it, apparently.
And he became known for being quite harsh. Famously fired a secretary over her weight, would tell assistants to go change if he didn't like their clothes. Very fastidious.
And his diet became extreme, too.
Very much so. Strict vegetarian, living mostly on milk, bread, honey, vegetable juices towards the end, almost ascetic.
And the rivalry with Edison? That never really faded, did it? Even after Edison died.
No. When Edison died in 1931, the New York Times asked prominent people for comments. Tesla apparently submitted the only negative opinion. Couldn't let it go.
Yet, despite everything, the lab fire in '95 that ruined him financially, the failure of Wardenclyffe, dying poor, his core contribution, it wasn't just preserved in museums, it's literally written into the language of science.
That's the ultimate testament, isn't it? In 1960, the SI unit for magnetic flux density, that fundamental measure of magnetic force, the force behind his AC motor, the force driving modern industry, was officially named the Tesla. His name is inseparable from the science he shaped.
What an incredible story, driven by this unbelievably pure imagination, almost otherworldly, yet constantly tripping over the practicalities, the money, the human element.
That's the central tension, I think. The almost perfect efficiency of his mental visualization process, slamming against the messy, profit-driven world he wanted to revolutionize.
Edison got the rewards for being practical, for managing teams, for bearing financial risk.
Right. While Tesla, the purist who could design a flawless turbine in his mind, suffered because he couldn't quite translate those leaps into viable, monetizable steps the world could digest at the time.
So as we sit here, benefiting every second from his AC innovations, what's the final thought, the provocative idea you want to leave our listeners with?
Well, think about that core contradiction we flagged earlier. Tesla was the ultimate believer in a mechanistic universe. He devoted his life to it, saw himself as an automation, lived by rigid rules like dividing by 3. Life was mechanics.
Right.
Yet, when he looked back in his own life, surviving all those near-fatal events, drowning, cholera, accidents, that terrible nervous breakdown, he didn't attribute his survival to physics or medicine or sheer luck. He claimed his preservation was indeed the work of divine power.
The divine power.
Yeah.
From the ultimate mechanism.
Exactly. So you have to ask yourself, what does it mean when a mind like Tesla's, so devoted to rational scientific explanation, so convinced of life as automatism? What does it mean when he feels compelled to attribute his own improbable existence not to science, but to something entirely beyond it, a divine power? It suggests even his extraordinary mind wrestled with the sheer unlikelihood, the mystery, of simply being alive.